Hello, my name is Gavin Stearman, and I'm the Director of Cowboy Rocketworks here at Oklahoma State. During this video, me and my fellow team members will be going over our designs, optimizations, and setups for our Argonia Cup rocket that we've named Caddie. This year, we will be flying a two-stage rocket that has to hit a minimum of 200 feet per second and carry a payload of golf balls to an altitude that will give us a score. The big consideration for this year is the number of golf balls you can carry, because that is a multiplier towards your altitude. It's much more efficient to carry more golf balls than it is to hit 45,000 feet. And so this year we have opted for a 4-inch design that finds a really good local minimum between golf balls and altitude. And so we've chosen to fly that 4-inch tube because it allows for a good packing factor that we'll cover later, as well as a solid altitude without excess drag. Our team structure for this contest works under 3 sub-teams led by systems engineers and then headed up by myself, the director. Our systems engineers help coordinate with our team leads to make sure that all of the different parts of the rocket are getting worked on, designed, and manufactured. Our teams consist of avionics, structures, and propulsion. Each of those works on their specific part of the rocket, optimizing it, and then putting it together with the help of the systems engineers and the directors before we start construction. This allows for each team to independently develop their stuff without having to collaborate, and allowing the systems engineers to take care of that effort. This allows each team to focus more specifically on the parts of their rocket, and then we can put it together later with the help of our systems engineers and then with the direction of myself. This has allowed us to put together a very efficient and well-designed rocket that we expect to be very competitive at this year's Argonia Cup.
Hello, my name is Carson Crull. I'm the president of the OSU Space Cowboys and the structures team leader for Cowboy Rocketworks. For Caddie, we conducted an altitude versus payload analysis, also taking into consideration our body tube diameter in order to maximize our score for the competition. In addition to this, we took measures to reduce drag by adding boat tails to both the sustainer and booster stages of our rockets, and we tailored our flight profile as well as our motor selection to maximize the efficiency of our impulse. Due to our optimization, our rocket has a high finesse ratio, and to mitigate the effects of body lift, we decided to go for a high stability design.
I'm Trey Durrell, and I'm a systems engineer and the propulsion team lead for Cowboy Rocketworks, and I'm going to be going over the design optimization of our rocket. We utilize OpenRocket for modeling and simulating our estimated stability, apogee, and speed. We also use OpenRocket to help with our motor selection. We've opted for a higher impulse motor on our sustainer due to its higher efficiency. We've also opted for a 4-inch body tube because it's commercially available and it suits our packing factor without the need for a golf ball holder.
I'm Carter Swallow, the avionics lead. This section will be about avionics. The sustainer has a Telemega as its primary computer and an Easy Mini as its secondary computer. They are independent of each other with their own sets of switches and batteries, and they are set in a dual deploy configuration. The booster has a Telemetrum as its primary computer and an Easy Mini as its secondary computer. The backup charges fired by Easy Minis are bigger than the primary charges. This is to ensure the parachute deploys, and they each have a 2-second delay. Tracking is done via AltaOS, Droid, and Yagi.
Hi, my name is Lauren Stearman. I'm one of the systems engineers, and I will be covering the recovery portion of this video. So we will be using a dual deploy on the sustainer and a 60-inch main that deploys at 1,500 feet. We will also be using a 24-inch drogue at apogee. For the booster, our 44-inch main will deploy at apogee, and we think this will be sufficient because of the lower altitude flight. Both stages will be tracked via AltaOS using the onboard Telemetra and Telemega, and to supplement the GPS tracking, we will utilize a drone for search and recovery in order to guide our recovery team to the rocket. We would like to thank our advisors, Dr. Jamie Jacob and Dr. Alyssa Avery, as well as our club mentor, Andrew Walsh. We would also like to thank the Zink Center for Competitive Innovation, as well as the Oklahoma Aerospace Institute for Research and Education. Thank you.